Okay, now that we've introduced some of these different types of fuels, let's just focus a little bit on specific types of fuels. And we're going to start off with fossil fuels. The first one we're going to talk about in terms of the heading of fossil fuels is going to be crude oil. Now, crude oil in and of itself, pretty useless, I'm not going to lie to you. But what you do is you got to fractionally distill this bad boy. Now, essentially what that means is you pump the crude oil here. This is a fractioning column. It has different levels here at different temperatures. Essentially what happens is crude oil, it's a mixture of different hydrocarbons and things like that. It's not a pure substance in and of itself. But if you put it in this fractioning column, and this is at different temperatures, so 200 degrees Celsius, maybe this is 400, this might be closer to about 800 degrees Celsius, it separates the crude oil based on on the individual components' boiling point. So up here you might get stuff like methane gas. Here you might get petrol and diesel, and here you're going to get something like C25 plus hydrocarbons, right? Really long chain stuff, and that's going to be things like bitumen and kerosene, which you're going to use for lubrication, paving roads and things like that. In this middle section, you're going to get things like petrol and diesel, other sort of motor fuels and things like that. And as I mentioned before, at the top you get these sorts of gases, right? You don't really need to know much about crude oil other than it has these constituent parts and how you separate them using fractional distillation. But other than that, that's pretty much all you need to know. Okay, the second fossil fuel that they really want you to know about is coal. Now, coal is also pretty straightforward. The main thing with coal is that there are different types of coal. Not all coal was created equal, so to speak. So, and it really relates to how much carbon is within the coal. So you have peat, which is roughly about 60% carbon. And this has an energy content of roughly 17 kilojoules, that's kg, kilojoules per gram. And compare that to something like brown coal, which has a bit of a higher content of carbon at around 70%. Let's erase that. Closer to 70%, my apologies. That has an energy content of closer to about 20 kilojoules. And then finally, black coal has the highest carbon content at 90%, and it has an energy content of 32 kilojoules per gram. So you can see a clear trend here that obviously the greater increased carbon content is equal to increased energy content. And that's the main thing you need to know with coal. The other thing that is not really too relevant in terms of an exam point of view, but maybe something that might come up in your SACs and things like that, is Australia has very high coal stores and coal sort of resource areas. And so a lot of our electricity and things like that come from coal-fired power stations. So that's another thing to be mindful of. Okay, so the third fuel that VCAR really wants you to know is petrol. This one, again, very straightforward. Most common fuel for motor vehicles. The main sort of thing with petrol is that the main component is octane. And so whenever you have sort of an equation regarding petrol, they'll often say like the main component is octane, just assume that it's all octane. So that'll be C8H18. And that has an energy content of roughly 47.8 kilojoules per gram. So as you can see, a bit higher than coal. So yeah, that's the main thing with petrol. Okay, so the fourth fossil fuel that VCAR really wants you to know about, and I'm going to go a bit more in depth in this one, is natural gas. Now, with natural gas, there's two main components with natural gas. Natural gas itself is just really a combination of methane, propane, and butane. So it's just those smaller chain hydrocarbons. So that's CH4, C3H8, and C4H10. With other hydrocarbons in there as well. Mainly methane though, which is very important when we compare this to biogas. But the main thing with natural gas is there's two common sort of distinctions, and the distinctions of natural gas are primarily based on the source of the natural gas. So you have coal seam gas, which is one that's specifically mentioned within the study design. It's also called CSG, which is the acronym. And you also have shale gas. Now, just to elaborate on these two, coal seam gas and shale gas are pretty much the same sort of thing in the sense that they describe where the gas is sort of trapped by. So in shale gas, it's obviously trapped by shale rock, which is just a type of rock. You don't really seem to know too much about it. And coal seam gas is trapped by the surfaces or the pores of different coal veins and areas of where coal is found. And so essentially what is important about understanding these two different types of natural gas is, if we come down here, is a process called fracking. Now that's the main sort of important sort of environmental condition you need to know, or environmental consideration you need to know when it comes to natural gas. So if we have, say this is a pump, it's a pretty interesting drawing. We have the ground here. We have sort of a water table, there's just water here. And finally, we have a layer of rock. So let me just add a little bit more. Maybe we can chuck some different colors in here. Let's go for some green. Jeez, this looks interesting. Not an artist. But yeah, the main sort of thing with this is you'll have this sort of, this will be a pump. And essentially what the pump does is it has a direct line into, this might be shale rock or a coal seam. And essentially what it will do is at high pressure, water and sand and other chemicals will be pumped in, and it will cause the rock or the coal seam to break into these fissures. Essentially what happens is that these fissures allow the gas to come out, and then they can be pumped back up to this pump and then stored for whatever purpose, etc., etc. Now, the thing is, with this sort of process is obviously you have a water table here, right? This is groundwater or whatever. Obviously, pumping in chemicals and things like that at a high pressure, you're bound to maybe have some issues with contamination. And when fracking was legalized in Australia, in Victoria and New South Wales in particular, there's actually a lot of protests because people were concerned about the environmental impacts of this process. So it's a bit controversial in that sense. And that's just sort of the main thing you need to know with regards to natural gas and fracking. So that's one sort of negative aspect of natural gas production or natural gas usage in Australia, because these chemicals can cause impacts to their environment, contaminate the water supply, and also if they're exposed to humans, they can cause lots of different diseases and can be carcinogens or cancer-causing agents and things like that. So yeah, that's the gist with natural gas. Another thing with natural gas is that its main component methane has a energy content of roughly 55.6 kilojoules per gram. Okay, so the fifth and final fossil fuel that I'm going to discuss today is liquid petroleum gas, or LPG. Essentially what happens is the propane and the butane from natural gas, so that's C3H8 and C4H10 respectively, is pressurized and it forms a liquid, essentially. Now again, pretty straightforward, nothing really beyond that is required for the VCE exam. But another thing I will point you to is that it has an energy content of approximately 50.5 kilojoules per gram.